Hello, I'm Peter Kuffel and this is my Lab 5 video. So first I have the MATLAB simulation code. This simulates the response of the RC circuit. The blue curve here represents the response of the 10 kilo ohm resistor circuit, and the orange curve represents the response of the 100 kilo ohm resistor circuit. The blue curve is a much faster response than the orange curve, which makes sense because the time constant tau is equal to r times c. So a smaller r means a smaller tau and thus a faster response. All right, so next I'll move into my Arduino code. So here's my Arduino code. I start by defining my variables, and I have my two different r's that I can switch between. And then I set my v in to 0 for 5 seconds in the setup function, and then in the loop function I set my v in to 5 volts and hold it for 10 tau seconds, and then I read the value every tau over 50 seconds, and then I set v in to 0 volts and do the same thing again. So in these for loops, I have it analog read the value of both Vin as well as Vc, and then put these into a string output for processing, print that output, and then apply the tau over 50 second delay. Or rather, tau over 50 millisecond delay. So 500 iterations of this for loop equals 10 tau, which is the delay that I ultimately want for holding my Vin at 0 or 5 volts. So in the serial monitor, which I'll pull up here, in the serial monitor, you can see that Vin, in just a second, you can see that Vin instantly jumps between 0 and 5 volts, while Vc has a slight lag in the response time. All right, so next I'll go to processing. So the first thing that I changed in my processing code was the baud rate. Next I added horizontal axis lines, axis labels, and then I set up the legend. So first I'll demonstrate the code with the 10 kilo ohm resistor in there, and then after that I'll show the 100 kilo ohm resistor. All right, so I'll wait for it to refresh and then show the 100 kilo ohm resistor. There we go. So now I'll just change this to 100 kilo ohms and swap out the resistors on my breadboard. Do that. Okay. Now I'll run the processing code, and you'll see that the response time is going to be much slower, so you can see that. So I'm not going to wait for it to refresh. That'll take way too long. Okay, so next up I'll show the analysis MATLAB code. So if I run it, I'll show the outputs for both the 10 kilo ohm circuit on the left and the 100 kilo ohm circuit on the right. So if I zoom in to show just one period for each, you can see that the tau for the 10 kilo ohm resistor is about half a second, and then the tau for the 100 kilo ohm resistor is about 5 seconds. So a much higher tau for the 100 kilo ohm resistor, which is consistent with what we'd expect. Thank you.